In this video, I'll be going over the unique paths leak code problem. And to start off, I'm going to read out the problem description. There is a robot on an M by N grid. The robot initially located at the top left corner, grid 0, 0. The robot tries to move to the bottom right corner, grid M minus 1, N minus 1. The robot can only move either down or right at any point in time. Given the two integers M and N, return the number of possible unique paths that the robot can take to reach the bottom right corner. So with this problem, it's asking you to take into account that it could take, multiple paths. How many possible paths are there? And to start off, let's look through the understanding portion. In the understanding part, I have two examples where we're looking at things. We have a row of three rows and a column of 7. So 3 down, 7 to the right. And interestingly enough, that I try this, I was thinking more of like an area problem, but we are not doing an area problem. We're just trying to find how many spots. So it's like a grid, almost like a chessboard. And through the examples and through the planning, I'll walk us through what I mean. So yeah, so we're trying to get from 7 times 3, that's 21. Unfortunately, that's not what we're looking for. What we're looking for is 28. And same thing with 3 times 3, or a 3 by 3 grid. It's not going to be 9, it's going to equal 6 because there are 6 possible ways, and 3 and 7 is 28 possible ways. And it can be the same way vice versa. So I could have 7 here, I got 3. Alright, what gives? I switched the numbers up. Any difference? No. Still going to be the same because you're working with the same amount of grids. And that's kind of what we're looking at. It's a little hard to show without like the visual portion, but I'll get to where I mean. In this solution, we are going to be taking in the account of how many times we turn left and right and organize it. No, we're going to do it in a mathematical approach and how we're going to do this. So in this mathematical approach, looking at the matching portion, what this problem gives me in the back of my head, because I am working with a grid, we are working with a 2D array, and we're going to be working with a 2D array of zeros. A 2D array of zeros, that's going to be our list of zeros. So there's a trick in Python where we can initialize a bunch of empty spaces, or zero spaces. I call them empty spaces. And we multiply them by the length you want it to be. So it would be zero array of 0 times n, and then we would have our for loops. We are going to be using for loops. This is what's going to help us make our 2D array. So to start off with the planning portion, let's actually start about that 2D array I was talking about. So in the first planning part I have here is we're going to take in row and column numbers, and we're going to create a board length of r of row length plus 1. So in this example, I'm sticking with the 3 by 3 because it's easier to show, and I don't want to have like 7 cross or down, so 3 seems more reasonable. And this one I have where my r equals 3. My row is going to be 3, so I'm going to go down, right? My rows are going to be down. Or excuse me, across, but I have it down here. The example is up and down. So anyways, I would have it be at 3. However, I want to create an r plus 1 because what we're going to be doing is we're going to be taking to the right of it. But right now we're trying to extend our range, so we're not out of bounds when we're doing the math. And again, I'll show you when I get there. So what we want to do is we want to initialize a set of zeros. So we have our rows. We have our rows to begin with, and it would look something like this. So this is just gonna. So we have 3. So 3 plus 1, that's 4. So we would have 4 zeros. That's what we have here. 0, 1, 2, 3. That's what we want here. Next is we're going to actually go through the for loop of each index. So for every 0, we're actually going to slap the actual column in there. So we're going to replace the 0 that's up here with an array, if that makes sense. So how we're going to do that here is, again, I'm sticking with 3 and my column is 3. So I'm going to have a row of I. So let's say let's see, 0. So uh, for I in R, again, we're going to do that. And we are actually going to go ahead and put the array of, again, a list of zeros times the column plus 1. Again, the point of this is so we can have an extra range, so when we're doing the math, we're not being told we're out of range. So the way it'll work out is, so up here, I have it at 0, and then the column, the first column, is actually going to replace that 0, if you notice, is an actual integer. But starting here, this is index 0 is right there, and it's an integer. In the next part, we're replacing index 0's number with an array, and we're following all the way that through 0, 1, 2, 3. That's all we're doing. So we now have our board. That's perfect. That's what we needed to do. We're going to loop through it and end up at our board of a 2D array. And I have it set up like this so it's more visually easy to see. So what next? We have our board. What's so special about this board? Well, to start off with this mathematical part, we need to start at 1. So the way it would work out is that at the very beginning, 0, 0 is where we start. And let's see if I can highlight it. So right here, 0, 0 is where we start, and that's where our robot's going to be. And we need to find how many possible paths it is to get from grid m-1, n-1. So, because we are starting at the top left is 0, 0, meaning that is path number 1. We visited it. That's 1. We start at 1, so that's only one possible way to go. All right, so there we go. We have it from there. The next part is we're going to have a nested loop where we're actually going to take, the way we're going to do this is we're actually going to go ahead and, without looking at this example portion right here, let me actually show it right here. So in this example, I have this. I want to go to my right. That means there's only one possible way in. So that's also one possible way. That's one possible way. And because I am focusing only 3, I only have the 0 so I can have the index. So I can have the list and range. So that's how this would work out. All right, and so all I'm doing is I'm taking index 0. I'm taking my index plus the index next to it and below it. And that's all I'm doing. So 1, let's see here. Let's actually start over with this one because I didn't make that clear. So the way we're going to be doing this is we're going to go 1 plus 0 plus 0 right here in this index. Well, that right here is going to equal 1. Same thing through. Now let's look at this part. 1 plus 0 plus 0. Well, that's going to equal 1. Okay. Now, that's how that goes. And again, this is going to be ignored because we just need it for the length, for the range. Because up here it's asking us for m-1 is asking for the grid m-1, n-1. And that's why we have it set up like that, just because of that reason. So going through, let's go to our second row. Same thing. So here we are. We have 1 plus 0, 0. We're going to go 1. It would be from like up here and then down to the right. That's how we're doing it, from up above to the right. Now we're at this portion, we're at this index right here, index 0, 1, 0, 1. So 1, 1 is our index. So how are we going to do this? So we have above us is going to be 1, and then next to us is going to be 1. That means this is going to be turning to a 2. So this makes sense because we take one pathway, this is one possible way, this is another possible route, but the moment we turn to the right, that's a second route, that's a second possibility, and we're just adding on to that. So on this index, 2 plus 1, and that's going to equal 3. Now that's 3 possibilities. All right, so now we jump into our next part. All right, we're going one way possible, one route down. So just to jump it, now that I kind of have that kind of explained in, we could just jump into having our first indexes all, oh, except for this one, all ones. Yeah, that's how we would have it, all ones in our first row in our first column. Now the next part that we're going to be doing is this. All right, so 2. Now let's go ahead and jump down here. So what about here? 1. Oh, sorry, 0. So behind it is going to be 1. And then above it is going to be 2. So 2 plus 1 is 3, and that's how we're going to get there. And then we're on to our last grid. So again, same pattern. We're going up. We're counting up again. We are counting up. So 0 plus 3 plus 3. Well, 3 plus 3 is equal 6. So we just jump to 6. And that is how we get 6 when we have our inputs of right here, 3 and 3. And that's how we get 6. Because we're just going through this mathematical, what almost feels like a Fibonacci sequence of just taking the number next to us plus the number next to us plus the number previous. And the moment that we get down is that when we start taking the ones above us, that's why we need the range for it. That's why we need an additional 0 in there so we can keep adding the one next to it. So it would be 0. So we would start from here. It would have been, let's actually use this one up here. So having 0, we want to use the one next to it. 1 plus 0. And then also plus 0 right here, because we're kind of going in that. Let's see here. So if I were going to use a 2D array, I would use I and j, right? So in this case, I would be doing this number right here, I and j, whatever it is. It would be board I minus 1. So I is kind of confused myself there for a bit. So I would be my row and my j would be my column. So in this case, I want to check this number right here, the 0 on the second, on the first index, on the first row. Yeah, okay, the 0 right here basically. I want to go ahead and take the number behind me. So it would have to be I. It would be index I, and then actually right here, I could just show you it. I and 0. So this is the number I'm at, and the way it would be is I would take the number I'm at plus the number below it plus the number behind it, and that's how that would be, and that's how that would end up working out. That's how we would get this equation right here. And then of course from the end we would return we would end up returning our board of row and column indexes. The explanation could be a little weird because I am trying to change it as we go. I don't have like an actual picture to show, but this is, I feel like, the best I can do for notes. So now I actually get to the coding part, what we're all here for. Now that we have our planning, let's implement this. So let's start with step one. What do we have? We have take the two inputs, our row and our column. So of course, without looking at it as in a function, let's just say r equals input actually we would have it as integer input and copy that, and then this time we're actually going to have our columns, so we would have C and R, row and column is how we're going to be using this. Okay, so we have our first integer, we have our inputs. What's next? Next is we need to create our we need to declare our zeros. So the way we're going to be declaring our zeros is, of course, we are taking the R. So this means that our board is what we're going to call it. We're going to have a list of zeros. We're going to multiply that by R. Actually, we would have in parentheses, otherwise it will be, the math will be all funky. So R plus 1, like we had before. And this is how we're going to have our first array of zeros. We're just going to start with 0 so we can have, something in the memory. Next, what we're going to be doing is we're going to be having a for loop that in our second step, we're going to for loop through each index and set our row of zeros inside and replace our integers. Okay, so the way we would do this is for I in. I'll just let that be. Never mind, it's bugging me. Alright, I in R course plus 1. So this means that for I in range, of 3, in this case, we will be having our column. So how do we have this up here? Yeah. Okay, so then this means that for our board of I, right? So we're going to be starting at, say, 0, our index of 0. Of that number, we are going to be replacing it with 0 times, and that's going to be our column. Of course, the parentheses is needed. Column plus 1. And that's how we're going to be getting all our zeros in to begin with here. We're replacing all our integers with arrays. That's what we're doing here in this part. After we're done with that, so the next part is we actually need to declare our board. So how do we actually access these numbers? Well, or the zeros inside the 2D array. So we would have our first, let's see here, our first row. So that means that we're accessing the list, the general list of the 0 index, and then we're actually going to access the actual element. And that we're going to declare to 1. That's how we have our board up here to be 1 on this guy. Yeah, I have it set up here. 0, 0, coordinate 0, 0 is 1. All right. Now, next we have to make a nested for loop, as in step 3. So we would have a for loop of R of row and column. So this means here for I range R, of course, plus 1. And then we're going to have for J in range I, C plus 1. And that's how we're going to have to set this one up. Then what we're going to be doing is the actual math part. Now, to make it quick, I'm going to take this part from my pseudocode here. And I'm going to take the actual one we want, copy. I'll fix that. And that's going to equal this problem. Be easier like that so it's a little bit more visible. And that's what we're doing. So our I is the actual number. Our I may have did something. Yeah, whatever day I ended it. Okay, so let's look at it real quick. So we have our I and J. I and J, let's say it is this number right here. This one would have to be 0. 0. Or I guess, yeah, that actually made sense right there. So 0. Just for this example. So this is going to be your I and J is what we're looking at. We're going to add the number behind it. Let's actually do it like this so we can focus on this little 2x2 area. So we have our I and J is this 0 right here. We're going to add it to itself plus the number below it. This is I, J minus 1. This is 0 plus I minus 1. So we're here. I is going to be 1 back and J is 0. So 1 plus 0 plus 0 is just going to be 1. And then we will replace that with 1. And we're pretty much doing this all the way through for each element. And then in the end, after doing what we did here in this example, so this one would be 1, and then this one would be 1. This number right here would be 2. And that's how everything just collapses in with each other from the math. That's the trick to this. And then after everything is done, we're then going to return our index of m minus 1 and n minus 1. So we would then return our board R minus 1 and C minus 1. And that would be, and if we look at it too from our example that we did of 3 by 3, R minus 1, so let's say 3, we made it as 4 for this example. But 0, 1, 2, or excuse me, we would need it as 3. So 0, 1, 2, and this is 3 right here, R3. And 3 is technically this fourth one, this fourth 0, because that's how indexes work. And so we would subtract 1. So starting with C, we subtract 1. And then from from the row, we subtract 1. And we ended up at 6. So that's how that works out. And so let me index it. Take a moment to look at it. Take a moment to look at it. I'll set this right here. So under this I, all the way down here, is the actual code on how to do that. I'll leave that there for you so you can look at it, and I will paste it in the description too so it's easier to see. As a matter of fact, I will do that now with a copy. So yeah, that is how this coding problem will be solved. This one was a little lengthy, but it's just because the explanation was a little difficult for me to explain, because it took me a while to wrap my head around it, but once I saw it, it just kind of clicked to me. And I hope that when you do this, or when you look at the code, or when you try to do the planning portion yourself and you see, oh, okay, I see you had this one with this number, which was originally 0, and then that number here, which was originally 0, and now turns into 1, and this index with this number, 1 and 1 equals 2. Then you start to see how everything just kind of falls into place, like just that pattern with this, which is like the backbone of what makes the magic happen. The real magic is this math portion. So yeah, that's going to be the end of this video. Thank you for watching.